So I'm going to just do a little brief introduction. I think Surya is going to do most of the heavy lifting with the demo here today. Um, so this is really kind of the result of the work across dbGaP, ImmPort, and Kids First. And really, I alluded to this on the panel earlier about how the scientific use cases have really helped drive what we've implemented, help prioritize, help scope down, because as I think you've heard in the panels, like the scope of this can get very large. So really trying to find that first. We have a program manager on our team who likes to talk about the 1,000-pound taco and like what are those first couple bites that you're gonna do. And I think that was really the goal of having these scientific use cases of, okay, these are a couple bites that people are trying to do. They know they want to cross-analyze the different data. How do we use that to drive the demo that you're gonna see Surya do? So I've talked a fair bit about these on some of the different all hands, but today we're gonna really focus on the UDN use case and highlighting some of the data there of how we pull data from dbGaP and from Kids First. But we also have other models of this with ImmPort and also the pediatric asthma use case. And so again, kind of really anchoring on the scientific use cases, testing the FHIR integration, and really performing those analyses in CAVATICA. So just a little bit about the background, the science here. I actually saw Surya put up the CAVATICA logo. We were just talking about some of the history of CAVATICA. So if you all have never Googled CAVATICA, you'll find that it's the brown spider. It actually comes from Charlotte's Web, Charlotte a CAVATICA, with the idea being that rallying a bunch of a motley crew together to save an innocent life, right? So that's the idea here. So we are really rooted in how do we understand different pediatric disorders, diseases, and in this case, congenital diaphragmatic hernia, which is an awful thing where the diaphragm does not fully form, and you get all kinds of really bad downstream effects. Your diaphragm helps keep all of your organs in place, and so you can imagine what happens if you have different kinds of holes and gaps in them. But it's also a syndrome, a phenotype that's found in other kinds of syndromes, other kinds of issues. And so the team at Baylor was really interested in this question of, they had done some work on CDH, they had done some work on the undiagnosed diseases. How could we bring together those two different data sets to understand, why in some cases this is the disease itself, while in other cases, this is maybe just one phenotype of a larger disease set. And so that really drove, how do we get the phenotypes, how do we get the genomic data, how do we bring that in, and every step of the way. I think their group is really focused on biostatistical methods, and they were thinking, oh, okay, now that we know the data, how do we kind of reframe our statistical methods, what can we get? And it was a really good real life iteration that I think Surya will show the end result of, from an infrastructure perspective, what we had to build to support that use case.
Thanks, Allison. Okay. So what we will cover is a small piece of the entire flow. So, and thanks to Ming for this slide, and a ton of the work that has gone in here. So the key is that you have the UDN patients, and you have a bunch of variants, and you want to filter down the UDN patients into a subset. So the key goal here was using FHIR and DRS together. So starting with accessing dbGaP FHIR, which is a controlled FHIR resource, which is a very unique thing about dbGaP FHIR, is you get that information using your RAS passport, using a task-specific token, and then once you're connected to dbGaP FHIR, you run that query, you filter down the patients, and this is, so basically the steps would be, yeah. So that's the base FHIR URL for the UDN study. You filter the patient IDs down with this FHIR query. And then you're interested in phenotypes. So in this particular case, we are looking at HPO terms, human phenotype ontology terms. So you pull that in, and now there is a resource, there is a FHIR resource called FHIR DocumentReference, using which you pull in the DRS ID. That is the connection between phenotypic data from dbGaP FHIR to a file, which is authorized access only. And then once you attach it to these DRS files, now you have a manifest. So now I'll jump into CAVATICA, and let's see, I'll log in. So if you have not seen CAVATICA, so this is the login screen. Once you get here, today, you log in with your ERA Commons. So this redirects you if everything is working in the world of live demos. Right, it takes me to RAS in action for those of you who have not been fortunate enough to see it. You log in with your ERA Commons. And now what's happening in the background is, so we are connecting through Gen 3 UChicago framework services. So CAVATICA went to Gen 3, went to RAS. I logged in. My RAS passport went back to Gen 3. Now CAVATICA gets back something called a fence token, which is a web token, a JOT for all authorization. I say yes. And now that handshake is happening. And I have to reload this because I was logged in so many times today. All right, so this is the project. So now what I just described on the slide, that's control data. So that's one more thing. So this is the dashboard of a CAVATICA project. We will not be looking at the raw control data, but what I want to show is how we can bring that in. So that DRS manifest, which we got from the previous step, I can go and add a file, and I have created a mock file for this particular experiment because, as I said, it's control data. So what this is doing is now we have a GFOGH DRS manifest import feature inside CAVATICA, where you can select a manifest file which has got DRS URIs and metadata, and this metadata came, this mock metadata came from dbGaP, and so that is uploaded. Great. So I X this out. And so what is happening right now is that the file is getting ingested. Just a second, I'll do one little thing here. Yeah, we go to the manifest one, and I select the mock file. And now I can add tags to it. So since I've already uploaded it, I'm going to call it dbGaP FHIR DRS. And now what's happening is those DRS URIs are getting, so it's importing those DRS manifests. So each line in that manifest file, and let's look at it while this is happening in the background, is, if I scroll to the right real quick, I'm sorry for, yeah, here. So each one of these DRS URIs is pointing to the NCPI DRS server. It's pulling in, and this is mock metadata, but you can at least see some examples from HPO terms here. And now the idea is that once this ingest is complete, now you can see all those files inside the project. So if I go to the files and I go to the FHIR DRS directory, so these have been imported. And now each one, let's say, let me click on this. So it shows you inside CAVATICA that it's pointing to this NCPI DRS server. And I don't have UDN dataset access. So I am not able to download it, but somebody like Ming who has access and other people on the research team, they would get this project with all these DRS URIs with metadata. Note this is mock metadata connected to those files based upon which they can run their workflows. So this was an idea to bring in FHIR resources. So we started with dbGaP FHIR queries, pulled in patient IDs, pulled in phenotypic data, plugged that into DRS URIs, and now you have an active project inside CAVATICA with both of those together, ready for analysis. So this was the place where those two come together. Any questions? We do have a little bit of time before the next demo.